The device you're using right now contains billions of microscopic electronic switches working together at incredible speed. They power smartphones, laptops, satellites, self-driving cars, artificial intelligence, and the internet itself. Yet every one of these technologies begins with something so ordinary that most people never give it a second thought. Sand. Not gold, not rare metals, just sand. This is the extraordinary journey that transforms ordinary sand into one of the most advanced products ever created by humanity, the computer chip. Imagine waking up tomorrow and every computer chip on Earth suddenly disappeared. Your phone wouldn't turn on. Traffic lights would stop working. Hospitals would lose critical medical equipment. Airplanes couldn't navigate. Banks couldn't process transactions. The internet would simply cease to exist. Computer chips are the invisible brains behind modern civilization. Every message you send, every video you watch, every GPS route you follow, and every AI system you use depends on billions of microscopic transistors working flawlessly every second. But despite their extraordinary complexity, their journey begins with one surprisingly simple material. Surprisingly, not all sand can become a computer chip. The sand used in semiconductor manufacturing contains large amounts of silicon dioxide, better known as silica. Silica is the primary source of silicon, the essential material used to manufacture semiconductor devices. Although silicon is one of the most abundant elements on Earth, producing chip-grade silicon is incredibly difficult. Even impurities measured in just a few atoms can affect performance. Before a single chip can be built, engineers must transform ordinary silica into one of the purest materials ever produced by humans. That remarkable journey begins with intense heat. Inside massive industrial furnaces, silica is heated together with carbon at temperatures exceeding 2,000 degrees Celsius. The extreme heat removes oxygen from the silica and produces metallurgical-grade silicon. But this silicon is still nowhere near pure enough for computer chips. It must undergo multiple refining stages to remove even the smallest traces of contamination. Eventually, the silicon reaches purity levels exceeding 99.999999%, among the purest materials ever created by human engineering. Only then is it ready for the next extraordinary step. The ultra-pure silicon is melted inside a specialized furnace. A tiny seed crystal is carefully lowered into the molten silicon. Then, over several days, engineers slowly pull it upward while precisely controlling its temperature and rotation. Atom by atom, the molten silicon aligns itself into a single, perfectly ordered crystal. The finished crystal, known as a silicon ingot, can weigh hundreds of kilograms. From this single crystal, thousands of powerful computer chips will eventually be created. The massive silicon ingot is then sliced into extremely thin circular discs, known as wafers. Each wafer is polished until its surface becomes almost perfectly smooth. The level of precision is astonishing. If a silicon wafer were enlarged to the size of a football field, its surface imperfections would measure only a few millimeters. Even a single speck of dust can ruin millions of dollars worth of computer chips. These flawless wafers now become the foundation upon which billions of electronic components will be built. The wafers now enter one of the cleanest manufacturing environments ever created by humans. Inside semiconductor fabrication facilities, known as fabs, even microscopic particles floating in the air can destroy an entire chip. Using one of the most advanced manufacturing techniques on Earth, engineers project incredibly precise patterns onto the wafer through a process called photolithography. Layer after layer,
microscopic structures are added. Eventually, billions of transistors are formed. Many are smaller than some viruses. Together, they create the powerful circuits that drive every modern electronic device.
Not every chip survives the manufacturing process. Before reaching consumers, each one undergoes rigorous testing. Engineers push the chips to their limits, checking speed, accuracy, power consumption, and reliability. Only the chips that meet the highest standards move on to packaging. They are carefully connected to protective housings that allow them to communicate with other electronic components inside phones, computers, vehicles, and countless other devices. Only after passing every inspection are they approved for use. The finished chips are shipped around the world. They become the processors inside smartphones, the brains of laptops, the control systems of aircraft and vehicles, the engines behind artificial intelligence, the servers that power the internet, and the technology driving scientific discoveries beyond our planet. What began as ordinary sand has now become one of the most sophisticated products ever manufactured. Every smartphone, every computer, every AI system, and every modern electronic device owes its existence to an extraordinary manufacturing journey. From grains of sand and ultra-pure silicon to crystal growth, wafer production, and microscopic transistors, the computer chip represents one of humanity's greatest engineering achievements. The next time you unlock your phone, send a message, or use artificial intelligence, remember, the technology changing the world began as ordinary sand.